Okay, good morning, children. Today I am doing a topic of solution chapter that is vapor pressure. Vapor pressure. Uh, the numerical part of vapor pressure I will be concentrating more. So first, let us say what is vapor pressure. Suppose we have a liquid here. This liquid will be accompanied by vapors. They are accompanied by vapors, and they will be in equilibrium. And when equilibrium is reached, the pressure which these vapors will exert at equilibrium, the pressure which this vapor will exert, it is called the vapor pressure. And you have studied in class 11, vapor pressure depends on two factors. One is nature of the liquid, and another important factor is temperature. Like for example, nature of liquid like water, will have vapor pressure less than ether. Because ether is more volatile in nature than water. And another factor, temperature, vapor pressure increases with increasing temperature, that you have studied in class 11. Now, if here, suppose there are two liquids, A and B, so we have here a binary liquid mixture. Binary liquid mixture. Then what will happen is this vapor. This vapor will be made up of A as well as B. So now the total pressure, if the total pressure due to A and B is PT, then PT will be equal to pressure due to A, called the partial pressure of A, and plus pressure due to B, that is partial pressure of B. And applying Raoult's law, we can write here is that PA will be equal to PA naught chi A plus PB naught chi B, where PA naught is vapor pressure of pure A, PB naught is vapor pressure of pure B. Now in exam, you get a numerical on this. So I am taking up a numerical here so that we can find out the answer through this relation. So the question is so here is a numerical vapor pressure of chloroform and vapor pressure of chloroform and dichloromethane at 298 Kelvin are 200 millimeter mercury and 415 millimeter mercury. So these values are the values of PA naught and PB naught. Calculate the vapor pressure of the solution. So we have to find PT, vapor pressure of solution, prepared by mixing. We have mixed 25.5 gram of chloroform and 40 gram of dichloromethane. So what will be the vapor pressure of the solution? That is first question, and we also have to find out the mole fraction of chloroform and dichloromethane in the vapor phase. That is the second part of the question. So like this question is very important, so let us try to do this. So since we have this relation, we have to find out the mole fraction of this and this in the solution. So now first of all, CaCl3, its molar mass 12 plus 1 plus 3 into 35.5. This is molar mass of chloroform. Molar mass of chloroform you will get to be 119.5. Similarly, the molar mass of CH2Cl2, it will be 12 plus 1 into 2 plus 2 into 35.5. This is a molar mass, and we will get it to be 85. Then we have to find mole fraction of CHCl3. Mole fraction, is defined as mass in gram by molar mass. So mass in gram of CaCl3 is 25.5 divided by 119.5. This is the before finding mole fraction, we should find moles of chloroform, which is this, and this value will be this you have to find. Similarly, moles of 2 will be, here it is 40 grams, so 40 divided by molar mass 85, and here you get it will be 0.47. Okay, so so now you can find the mole fraction. So mole fraction of CHCl3 will be moles of chloroform 0.213 by total number of moles, the sum of these two, 0.213 plus 0.47. So this one you have to simplify, and on simplifying you will get this answer to be 0.312. And you have to find mole fraction of the other one also, CH2Cl2. That will be, we can do it from here, 1 minus 0.312. That is, it will be 0.688. So after we got the mole fraction of both the components, we have to use this formula. We have to put here PA naught and PP naught value is given. Suppose of chloroform, the vapor pressure given is 200 of chloroform. So it is 200 multiplied by mole fraction of chloroform, that is 0.312, plus, and vapor pressure of pure CH2Cl2 given in the question, it is your 415, and mole fraction of this, it is 0.6 88. So this you have to multiply, and the answer that you will get here, it will be 347.9 millimeter mercury. So this is part 1 of this question. Now the part 2 of the question is we are asked to also find mole fraction of this chloroform and dichloromethane in the vapor phase. So suppose in the vapor phase, it is, we call it as chi A prime and chi B prime. Mole fraction, as you know, in the liquid phase and vapor phase will not be same. And mole fraction in the vapor phase, suppose of chloroform, HCHCl3 prime, mole fraction of chloroform in the vapor phase. How do we get this? It will be your we get it in this way. The pressure due to A, which is this term we will write. So that is your pressure due to chloroform. It is this one. So 200 into 0.312, the pressure due to chloroform, and divided by total pressure. Total pressure is 347.9. So I am writing the formula here. Formula, how do you get this? Will be mole fraction of chloroform into P chloroform naught by P total. So to get mole fraction in the vapor phase, we have to use this one. We have to get the partial pressure divided by total pressure. So partial pressure divided by total pressure. This one, the value that you will get, it will be it will be 0.18. It will not have any unit, and to get the mole fraction of the other component, you have to subtract this value from 1 and you get the answer. So this is a very straightforward numerical, it comes in exam. Now I will be doing another numerical. So children, here we have that question. Vapor pressure of pure liquid A and B are 450 millimeter and 700 millimeter mercury. So here straight away PA naught value is given 450 millimeter, and PB naught value is also given, it is 700 millimeter. Then says find out the composition of the liquid mixture. That means here what we have to find, we have to find chi A prime. Sorry, chi A we have to find, chi B we have to find, composition we have to find, and it is given total pressure is PT, it is given to be 600 millimeter. So we have to find chi A and chi B, and also we also have to find the composition in the vapor phase. That is, we also have to find chi A prime and chi B prime also. So we can start like this. PT, it is PA plus PB, which is PA naught chi A plus PB naught chi B, and we can make one substitution here. Since you know chi A plus chi B, sum of the mole fraction is always equal to 1. So chi A will be equal to 1 minus chi B. So this we can substitute here for chi A 1 minus chi B plus PB naught chi B. So now let us simplify this. So it will be PA naught minus PA naught chi B plus PB naught chi B. Now let us take chi B common here. So PA naught, if I write this part first and take common chi B, so it will be PB naught minus PA naught. So this is what we got. Now we can apply these values. PT value, it is said to be 600. So I am writing it here 600. And PA naught value is 450 plus chi B we don't know. Here it is PB naught is 700 minus 450. So children, from this equation, we have to solve it and we can easily get chi B. So that will be our one answer. And to get chi A, what you can do is just subtract chi B value from 1, you get chi A. And after getting this, then as I already said you, to get this chi A prime will be your it will be partial pressure of A by total pressure. Partial pressure of A is total pressure that you have to use. And how much will be the partial pressure of A? That will be your PA naught chi A by PT. And like PA naught is 450 into chi A, the value of chi A that you are getting here, that value you have to put it here. We put it here. PT is given 600. So from here you will get the mole fraction of A in the vapor phase. This is also asked here. And after getting chi A prime, to get chi B prime in the same way, you can subtract chi A prime value from 1, you get the other answer. So this much we have to do, we are doing for this video. We must practice like this numerical, these are very important. We should watch these videos carefully in today's class. This much for now. Have a good day.